Hey, Ben.
Your job's a joke, you broke, your love life's the away. It's like you're always stuck in second gear. When it hasn't been your day, your week, your month, or even your year. But I'll be there for you.
Proteins are sophisticated and complex structures. They are the primary class of molecules in living things.
They are single-chain polymers made from monomers called amino acids.
Amino acids join together to form polypeptides.
Amino acids are made up of a carboxyl group, an amine group, a hydrogen group, and R side chain.
The carboxyl group gives each amino acid their acidic qualities.
This is an example of an amino acid structure.
A side R group is used as a placeholder to represent each amino acid and their individual qualities.
Proteins are one of four basic kinds of organic molecules.
They form many different structures.
For example, keratin is found in hair. Collagen is found in tendons and ligaments.
There are about 20 amino acids used in nature.
For example, alanine, valine, and leucine.
There are 4 levels of protein structures. The first one is primary. Primary structures are a sequence of amino acids linked together by polypeptides.
Primary structures are stabilized by polypeptide bonds. An example are amino acid chains of hemoglobin peptides.
Because of the R groups, they interact with each other to form long chains, which come to form the secondary structure. The secondary structure is the formation of alpha helices and B pleated sheets.
Secondary structures are stabilized by hydrogen bonds. An example is one alpha helix. And it looks like this.
With more H bonds and covalent bonding, it will form to become the tertiary structure, which produces its overall 3D shape.
They are stabilized by R groups. For example, one polypeptide subunit.
The fourth and final protein structure is quaternary. Its shape is produced by combinations of polypeptides.
They are stabilized by peptide bonds. For example, hemoglobin consists of 4 polypeptide subunits.
These are your 4 protein levels.
Proteins are crucial for most tasks required by the cell.
The 8 functions of proteins are catalysts and enzymes to speed up chemical reactions,
Defense,
Yeah, I took your chocolate milk, so what?
storage of amino acids, hormonal, transport,
Recepting.
Contractile movement, and finally, structure.
Changes in protein structures can affect different diseases like Alzheimer's, which affects the brain when adults age.
proteins and their neurons start to become misfolded and they become amyloids, which are clumps of misfolded proteins.
As amyloids build up, it interferes with the neurons, which are shown in black, and affects the ability to send messages, which leads to dementia and memory loss.
The same thing applies to a disease called Parkinson's. The only difference is that it affects a different area of the brain.
This concludes our talk about protein structures.
Hope you learned something. Bye.
Was that loud enough?